All right, you guys see some writing on this video already. I started the video and I messed it up. But anyway, all right, first thing, I forgot to say this last video, and this is all I was going to tell you after you guys get this done. You can start on the book assignments. They are on the last slide of the PowerPoint. I forgot to tell you that in the last video. All right, so the example we're looking at here, by the way, when you guys are going through this worksheet, do like the first two, do like questions 1 and 2, like the little scenario, and then the scenario in 3 and 4. Do that by hand and show the work like it's AP pre-response. For the rest of it, just use your calculator to get the answers and kind of see what the pattern or what the rule is. But on this one, we'll do it by hand. So basically, you're going to get a new car for college. You got a dealership that's playing a little game, a little promotional offer. You spend a little spinner. A fifth of the time, you win $1,000. The other 4/5 of the time, you're not going to win anything. So we're going to make a probability model. So 4/5 of the time is 80% or 0.8, and I win $0. The other 20% of the time of the 0.2, I win $1,000. And by the way, don't let this table throw you off. Capital X is the amount of money won. That's your random variable. So what it means when it says probability capital X equals little x, you just follow this table across. So here little x is 0, so this is saying this 0.8, that's the probability that capital X equals, and you look at the value above it, is 0. So the probability capital X, the amount of money won, equals 0 is 0.8. Then you look here, this 0.2 is the probability capital X equals, well, the little x here is 1,000. So the probability, this is just saying the probability of the amount of money won is $1,000 is 0.2. So don't let the way that table's set up throw you off any. Let's see. So expected value of X is 0.8 times 0 plus 0.2 times 1,000. I got 200 for that. The main reason I stopped this last video is I put in 100 instead of 1,000 over here. So we've got 0.8 times 0 squared plus 0.2 times 1,000 squared. If people make a mistake on this, a common mistake is they square the 0.2 and the 0.8 instead of 0 and 1,000. But remember, it's the expected value of x squared, so you're squaring the x's. So that ends up being 200,000. And I'm not going to write dollars there because actually the units aren't dollars. So the units are actually dollars squared. That means the variance is 200,000. It's the expected value of x squared minus the expected value of x, which is 200 squared. So if we do that, I get 160,000 for the variance, which means the standard deviation is the square root of that. That means the standard deviation is $400. It's the square root of the variance, so it's the square root of the 160,000. I tell you what, just to be safe, I would even show that. I can see a rubric like maybe even taken off for that. So we'll communicate that we know the standard deviation is the square root of variance. That's probably an important thing to communicate. All right, so we found the expected value of x. We did that. It was $200, and we found the standard deviation was $400. All right, so in part 3, now let's suppose whatever you spin on that wheel, that dealer's going to add $200 to it. So if I spin a 0, which will happen 0.8 of the time, 80% of the time, he's going to feel sorry for me and throw an extra $200 on there. So 80% of the time, I'll come away with $200 toward my car. The other 20%, I'm going to spend 1,000. He's still going to throw $200 on top there, so I'll have 1,200. So let's see how the mean and standard deviation change. So if we do the expected value, we'll get 0.8 times 200 plus 0.2 times 1,200, which that should be $400. All right, variance. I tell you what, for the sake of time, so this video is not very long, plus I can't upload it to Moodle if it gets past 20 megs. So for the sake of time, I'm just going to, instead of writing it out, I'm just going to explain how to do it. So expected value of x squared, do 0.8, and I'll actually do this in my calculator. So 0.8 times 200 squared plus 0.2 times, my bad, sorry, 0.8 times 200 squared plus 0.2 times 1,200 squared. That gives me expected value of x squared of 320,000. So we do the 320,000, the expected value of x squared, minus the expected value of x, which is 400 squared. So 320,000 minus 400 squared is 160,000, and that's the variance. So if we take square root of that, we should get 400. So that means, let's write this down somewhere. That means the expected value of x plus 200 makes 400, and the standard deviation of x plus 200 is still 400. All right, so that is a rule of random variables. And is that consistent with what we learned in Chapter 5? And it is. Remember, if we add or subtract a constant to all the data in Chapter 5, and now in Chapter 16 it's a random variable, what happens to the mean? Well, it'll add or subtract by that constant. So in this case, the old mean of 200 up here, when we added 200 to everything to that random variable, the mean went up by 200. So 200 plus 200 makes 400. But remember, when you shift everything over 200, the data of the random variable is not any more spread out than it used to be. So the standard deviation stays at 400. All right, so number 5, let's make the probability model. And again, you guys don't have to do this by hand if you don't want to, unless you really think you're just struggling with it. But let's do, what if he takes whatever you spend and double it? So 80% of the time I'm going to get $0. If you double 0, I'm still at $0. I'm going to switch to sync. I don't like the yellow. All right, and then 0.2 of the time I'm going to spend 1,000, but he's going to double it to 2,000. So either doing it by hand or using your calculator or doing both, you're going to figure out the expected value of 2x is $400. Should figure out the standard deviation of 2x is $800. And you should figure out the variance of 2x was, let's see, 800 squared is 64 and 4 zeros. So it should be $640,000. So what happened to the mean? Well, and remember, this is the same rules as Chapter 5. If we double everything, the mean should double. So it did double. So it multiplied by 2. It doubled from 200 to 400. What did the standard deviation do? It doubled from 400 to 800. What did the variance do? It actually multiplies by a factor of 2. But remember, standard deviation multiplies by 2, and variance is standard deviation squared. So it actually multiplies by a factor of 2 squared. So it actually quadrupled. If you guys remember up here, it was 160,000. So 160,000 times 4 makes your 640,000. All right, on the back of this worksheet. Now, what if they're going to take whatever you spend, they're going to double it, then add 200. So let's see, if I double 0, that's still 0, plus $200 is 200. 0.2 of the time I'm going to spend 1,000. They're going to double it, which is 2,000, and add 200, which is 2,200. So how are these things going to change? Well, the expected value of 2x plus 200, and again, use your calculator or do it by hand or both, but what you should figure out is, and this is going to be the same rules as Chapter 5, will doubling it affect the mean? Yes. So that mean used to be 200 when it was expected value of x. I double it. Here, this might help. Let's write this real quick. So expected value of x is 200. What would happen if I doubled x? Well, if everything doubles, the mean should double. What happens if I take that and add 200? Well, if I add 200 to everything, the mean should increase by 200. So this should be 600. You should have gotten $600, hopefully. All right, now what about the standard deviation? So remember, the standard deviation of x was $400. What should the standard deviation of 2x be? Well, if I double everything, it gets twice as spread out. The standard deviation should be twice as big. All right, now what happens if I add 200 to everything? Does that affect the spread any? And no, everything gets shifted over 200, so it's not any more spread out than it previously was. So the standard deviation of 2x plus 200 is still the same as the standard deviation of 2x. It's still $800. So you should have got 800 here. All right, so how did the mean change? Well, the mean, the multiplying by 2 changed it, and the plus 200 changed it. How did the standard deviation change? Well, it only multiplied by 2. So how did the variance change? It should multiply by 2 squared. All right, now finally, the last part of this is something, it's kind of a combination of what we're going to learn today and what we're going to learn tomorrow. We'll go ahead and talk about it a little bit, though. All right, what if instead of, now there's a difference. In random variables, x plus x doesn't equal 2x. Now this is a big difference. Be sure you understand this. 2x, remember x is spinning the wheel. It's the value that wheel comes up. So 2x is spinning that wheel. Actually, let me uncircle this. It's spinning that wheel once, which is x, and doubling that value. X plus x is spinning that wheel a first time, and then spinning that wheel a second time. So these are two very different things. And again, just to recap that, because that is very important. In random variables, x plus x is doing something twice. You spin the wheel the first time, you spin the wheel the second time. 2x is you spin the wheel one time, and whatever you get that one time, you double it, which is what we did in question right here, 5 and 6. All right, so let's make a probability model for this. What are all the possibilities? Well, one possibility is I spin 0 on the first spin and spin 0 on the second spin. Now remember, we're dealing with independent random variables. So what's the probability of that happening? By the way, I would win $0 if that happened. Well, the probability of spinning the 0 on the first wheel is 0.8. Probability of spinning 0 on the second wheel is 0.8. But since those are independent events, like we learned in chapter 14, we can multiply those two probabilities. So 0.8 times 0.8 means 64% of the time I'll spin a 0, then another 0, and win $0. Another possibility is I get 0 on the first wheel, 100 on the second wheel. The probability of that happening, again, these are independent events, so we can multiply, is 0.8 times 0.2, which is 0.16. Another possibility is I get 100 on the first spin, a 0 on the second spin, which is 0.2 times 0.8, which is 0.16. So there's two ways I can win $100. I could do it this way, or I could do it this way. So or 0.16, and or means add, so 0.16 plus 0.16 makes 0.32. So 32% of the time I'm going to win $100. All right, and then the other possibility is I win I'm sorry, I keep doing that, it's 1,000. And the other possibility is I win 1,000 and 1,000, and the probability of that happening is 0.2 times 0.2, which is 0.04, and that means I would have won 1,000 plus 1,000 is $2,000. All right, so, and by the way, guys, you should always do this. Whenever you make a probability model, kind of like that, using probabilities, multiplying independent events like we just did, always go add up your probabilities here and make sure they add up to 1. You know, all your outcomes should add up to 1. So here, 0.64 plus 0.32 makes 0.96. 0.96 plus 0.04 makes your 1. Let's see. So if you guys go through and do the work, we're just going to figure out expected value of x plus x makes 400, which is equal to e of 2x. So here it doesn't matter. If we spin the wheel once plus we spin the wheel twice, the expected value is going to be the same as if I spin that wheel once and double it. But here's where you got to be careful. This is a big distinction. The standard deviation of x plus x does not equal the standard deviation of 2x. Standard deviation of 2x was 2 times the standard deviation of x, so 400 times 2 was 800. This actually ends up being 400 radical 2 here for a standard deviation of x plus x. So you guys should have got something around, when you did this, hopefully you got something around $565.7. All right, and we'll talk more about why this happens tomorrow when we learn new rules. But some rules you should have learned. And I'm going to try to go to the PowerPoint. I don't know if this video will pick it up or not. Maybe it will, maybe it won't. But I'm not sure if you guys can see what I'm doing right now. But at the very least, you can hear me. So go back to the synopsis of the worksheet right after that intro to rules of random variables slide. And you're going to see 1, adding and subtracting constant to or from a random variable. You know, the expected value of x plus or minus c is expected value of x plus or minus c. You know, variance of x plus or minus c just ends up being the variance of x, you know, because when you add or subtract constant, it doesn't affect it any. Same thing for standard deviation. And then go to the other slide, which is slide 12. And, you know, it'll tell you what happens when you multiply a random variable times a constant. You know, the expected value will multiply by a constant, so will the standard deviation, and the variance will multiply by that constant squared. I hope that helps. Something that'll give you some feedback, whether it's helping or not, is the book problem. So try those. And like I said, if you're just completely lost, see if a neighbor can help you, and feel free to email me too, and hopefully I should be able to email back and answer.